Hey everybody, this is Larry. This is me going with Q4 of the weekly contest 275, earliest possible day of full boom. Hit the like button, hit the subscribe button, join me on Discord, let my Discord go on a full boom. Okay, fine, I don't know. That was terrible, but just having fun. But yeah, so this one, there is something called the, what did I call? I said it during the live feed, but the exchange argument. That's what I was thinking of. And this is and part of that is going to be greedy and sorting and so forth. The question is, but it is actually very simple in that there is some transitive property about this problem that may not be intuitive. But the idea is that okay, we have n where n is 10 to the 5th, I think. Yeah, so we have n flowers. The question is, how do you kind of put them in some order, right? So there is some kind of meta thing for me, to be honest, which is that if n is that big, I know that's not going to be an n square algorithm because that's just too slow. So I know that n log n is going to be fast enough. So I was thinking about a sorting algorithm. And to be honest, like I said, this is very meta. Like I didn't know whether that would be good enough. Or sorry, I knew that anything more than that is not good. So like, whether maybe it's dynamic. I'm not saying that this is dynamic programming, but during the problem solving, I think if it was dynamic programming, n would have to be smaller, or maybe it'll be a linear time dynamic programming. So these are the things that I'm thinking about, right? During the contest, just looking at the constraints, right? But here, because you're trying to figure out some ordering, I did rely on some kind of playing around and a little bit of YOLO, to be frank, during the contest, because there is a greedy argument, which is part of the exchange argument as well, which is that okay, let's say we distill everything to 2 flowers, right? So we only have 2 flowers. We don't have to, and we assume maybe in a greedy way that, like I said, the transitive property holds. Otherwise, I don't know how to solve it, to be honest, right? So I was giving it a YOLO shot. But yeah, so let's say we have 2 plants, and then the idea behind that then is, okay, let's say we have 2 plants. Do you put plant 1 first, or do you put plant 2 first? And from that, it's I mean, that one I feel like it's easy to kind of figure out the equation for. And that's what I did here. Yeah, okay. I don't want to spoil a little bit first. Sorry, friends, no spoilers. But yeah, but let's say we have plant 1, plant time 1, grow time 1, and then we want to compare to, and this is a little bit spoiler. I actually did this during the contest because I didn't want to write it out. So, but yeah, so we don't want to compare plant 1 to plant 2, where we have plant 1 time and then plant 2 time, right? With the planting time and the grow time. So we're going to compare. And then the idea is that, okay, let's say we put plant 1 first. What is, if we put plant 1 first, what is the length of the sequence, right? So it turns out that for here, well, if we plant 1 first, then, well, it takes plant 1 time, plus the max of this thing. And what is this thing? That means that we plant, and you could kind of draw it out, right? So P1 is, let's say we have 1, 1, 1, 1, 1. Is that a better representation? Okay, let's just say, let's say this is the planting time, and then now, let's just draw it out like, let's say I'm drawing out, these are the planting times, and then now we have the, the 2s, right? So then now we have this, for planting, and I don't know, for the flower, right? So this is the visualization that I would have for this formula, which is that, okay, P1 we have to plant, and then as soon as we can, which is after this finish, we plant. And also one thing is that on these examples, they always try to trick you with some weirdness. So look at it, but don't like always hold yourself to it, right? What I mean by that is that, like in this place, in example 2, there's some like weird gap in between the planting. But if you really think about it, like at least, especially even in this diagram, right? If you just swap around like the, if you just swap around when you plant stuff, like it actually doesn't matter, right? Like the, like you can move the first one on the row 3 to row 2 and then swap that down, and that doesn't change the answer, right? So that's basically the idea. But yeah, so now the idea is that don't let these examples fool you, because sometimes it can be. So yeah, so P1, like I said, so you plan as close as soon as possible in a greedy way, and then the total time of planning P1 first is going to be this. So there are only two cases, right? One is that the plan 2 time will dominate, so you have this entire length. Right? The other case is if you have you have a long growing period, so then it looks like this. So that's basically what this formula represents. So it's either this case or this case. Either way, we get the length of the entire what happens if you grow P1 first. And then now we compare it to the same thing with P2. This is the same visualization except for backwards, right? So we basically now look at what happens if we plan P2 first, which in this case, okay, I guess I changed these, so it doesn't really apply as much here. But yeah, but let's say we have this case, then now we put P2 first. Right, and then now we do P1. But yeah, but you get the idea. That's basically the formula that gives you the length of the that gives you the length of the thing. And then we want to return, okay, what's the better thing to grow first? So if this gives me the shorter time, I want P1 first, and or plan 1 first. And if this gives me the shorter time, then I want the plan 2 first. And that's basically this idea. And in Python, that's basically what I did with this algorithm. You look at my comparedor function, and this applies in every language. But in Python, it's a little bit awkward to compare by key. You have to do this thing that's from func tools that compare it to key. I actually, to be honest, it's kind of magic how that works. I have to look at the code. But I mean, you could write it yourself, but I just actually am very curious how this works now that I think about it. But now that you sort it by here, this is a comparador, whatever. It's a comparison. Wow, my English is bad. But yeah, it's this comparison between A and B, which is literally what we talked about. And then we just return this. And you could return this in different ways, like, just I think, but either way. And this is just like a standard sorting thing. So that's what I'm used to. Oh yeah, and I zip it together so that I have it in one tuple. And after we get the tuple, we just take it out. And then after that is just simulation, right? Okay. I mean, this is still tricky as well. Just make sure you're careful, which is that, okay, for every planning time and growing time in this sorted thing, you try to see, okay, what is the latest? The latest is the current time plus planning the PNG, meaning that you know that this current plan will end at current time plus PNG. And then that's pretty much the idea about this current latest. And then of course you move the current time to plus pre, because then now the current time is the next time you can plant a new plant. But yeah, and of course this is going to be n log n, because this is sorting, so that's n log n, and O of n space, linear space, because we do zip into list. You could do things in place, but I don't count that anyway. So yeah, so this is going to be n log n and O of n space for me. And yeah, and of course this part is just linear time, constant space, though it gets dominated by these two. So yeah, that's pretty much all I have for this one. So what we did here is called the exchange argument, I believe. So definitely, if you do want to learn more about it, yeah, if you want to learn about it, I guess Google it. Yeah, it is. Yeah, that's basically it. Definitely Google it a little bit and see if you can kind of understand that a little bit more. But that's all I have for this one. You could watch me solve it live during the contest next. What a silly mistake. Cost me 5 minutes. Okay. okay, so prime time is 1, 4, and 3. 1, 4, and 3. What does that mean? Oh, I see. So it takes 1 day, 4 days, 3 days. Okay. Look at the constraints. Okay, and it's big, so that means that it's sometimes sorting out. Okay. Oh no, it doesn't have to be continuous. What is the earliest possible day? Okay. Well, I think they drew this in a little bit weird though. Is that true? Well, someone already finished, and I had a yikes penalty, but that was a silly typo, or like just mental brain fart. But sometimes the examples are misleading. I'm trying to figure out if this is one of those cases, because when does it ever make sense to interleave? I cannot see this in a clear way, to be honest. That doesn't do anything, but that's fine. Okay. It's G plus current point time. Oh, this is just greedy. I don't know if this is right. Well, it's wrong for this one, so it's not. So we. That's good. I mean, better finding out that we're wrong now than in penalty. But okay, so greedy doesn't work, huh? Oh, maybe the other way. Huh. Actually, I was thinking about it, but 1092, I think that's still off. I was doing this one first. What is the optimal? So doing the 4 and then the 3. There's some function like that, right? There is the exchange argument. Okay, I need to use the exchange argument. That's basically it. Okay, so that's how people got it so fast, because some people are very good about this. So let's say we have the same time and we have these things, right? And that means that the full time is going to be P1 plus P2 plus, so it's going to be this is either, so we do P1 first plus max of 5.2 plus G2 and then G1 compared to P2 plus max of okay. Comparator. In Python, there's not an easy way to do comparator, at least. Does this work? I don't know if this works. I hope this works. Like syntax wise, I'm not sure about it. 992. Let's see if that works. Cool. Yeah, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. It's a little bit of a redemption round, though. I mean, I did okay. I think this is around what I'm expected. But yeah, let me know what you think about this problem explanation. Stay good, stay healthy, to good mental health. I'll see you later. Bye-bye.